So this talk will deal with the topic of MLOps. MLOps is the equivalent of DevOps in IT, but transported to the data science world. And I'll discuss the opportunities and challenges of developing models in an MLOps fashion, going back to my experience, which is in the financial sector mainly. Are you able to hear me loud and clear, by the way? Okay, I have a bit of echo coming from the right side.
Muted.
Okay, I have one commercial slide, this one to explain who I am and what we do. So my name's David van Abeele, I'm a physicist. I've been number crunching for 30 years now. I started in academia and engineering, then I moved to finance, so banks, insurances, and then data science came into the picture as well. I work in Credo software. We're a small company based in Antwerp, and in the Czech Republic we also have 2 people. And we provide heavy number crunching for companies in the Benelux, essentially. And a lot of that is data science and machine learning, and not so much making the models and doing the AI, but industrializing it, making sure that it works at a large scale, 24/7. That's what we do. So I had intended to go with my stand all through Europe this year, but everything is virtual now, unfortunately. So this is our fancy backdrop if I would be standing physically in front of you. You see from my suit that I don't have the right look, so normally I should have a beard and some tattoos and be wearing a Canadian shirt and so on, and I'm completely having the wrong look, and there's a good reason for that. For some reason I don't understand, I always become the boss in my career. It happens over and over again, and now again I'm the manager, and this will be the perspective from this talk. So if you came to hear somebody who has a lot of hands-on experience with 500 open source applications and data science algorithms, that's not me. I have more of an outside perspective. I spend my days supervising our implementations at customers and making financial companies data-driven. These are quite big, demanding customers, so it's quite interesting. If you have a technical question, nevertheless, my colleague Rado van Parak will be joining soon too from Prague.
And he's
okay. Hi, Rado van.
In the middle.
In the middle.
Yeah, Rado van Parak, next to Rado.
Yeah, hello Rado van, thanks for being there too. So he's really a hardcore data scientist, and he can answer any technical question you might have, I dare say. So my first bold claim is deployment is the final frontier of statistics. And to prove my statement, let's take a historical perspective. So I have here the scientific world on the bottom, the IT world, and the business world in the top, and the scale is almost logarithmic, but not exactly here in time. So statistics was invented by a compulsive gambler from Venice, I think. His name was Cardano, so he actually developed it to be able to gamble. And then it was reinvented many times again over the centuries that followed. And it matured, and a big change happened, of course, in the 1940s and 50s when computers were invented and the first notions of AI appeared. And then if you go to the 1970s, SQL databases appear, the first analysis. And then you go a bit farther, you see a first ML boom. You have SAS, for instance, going to the market, and people start doing statistics on data warehouses. On a large scale, you start having BI, and then around the year 2000 you have data mining as well. So that's an interesting development. That was not classical statistics. People start to use statistics actually for very practical purposes, other than gambling. The term data science appeared around 2001, I think, and became very popular towards 2010 and later. You all know that, I don't have to explain it. And then towards 2005 you have a boom of R and Python, you have Hadoop, so that's the beginning of big data actually. Hadoop, you probably know, is a kind of distributed file storage that allows to number crunch enormous volumes of data. The cloud appeared and DevOps started happening in IT, so DevOps is a way of very efficiently putting, for instance, websites continuously live. Okay, you have Spark in the past decade, so that's a parallel computing platform for data science. and that leads to the big data boom that you saw in business. And now, at the very end, well, you have some interesting things happening in IT. You have the idea of microservices, putting small things like scripts in small services that you can call in a flexible way. You have things like Docker and Kubernetes, I'll talk about it, and MLOps, which is the art of industrializing data science. And the question I ask myself often is this the last step of statistic, or there is more to come? Because for me, the problem really is not doing the statistics. We can do many analysis, there is almost no limit. The problem really is to put it live and to put lots of different types of statistics live. Okay, so my story here, in 2010 I became the head of a big team of quants in a large international bank. Quants are like data scientists, but they do the same as data science in the field of quantitative finance, but the methods are really the same. I had 16 people underneath me, and they were all making models, and that went very well. And every 2 weeks or 3 weeks, a new model would be ready for every member of my team, or an existing model would be changed. So far so good. But then it became really weird, because the models had to be fed to an IT team that would prepare them for going live. So there was the dev team, the development team, and a big Chinese wall between us and this team. So we would transfer the models to the dev team on, you guess, paper. And then they would start implementing. It could take a couple of months. Often they would get back to us and tell us that unfortunately the model we had made was not implementable, because they chose their own software for putting our models live without consulting us. Can you imagine? So you make a random forest algorithm and they come back and say, unfortunately you can only do linear regression type formulas, so go back and redo your whole analysis. That's the kind of stuff we were dealing with. Sometimes they would implement correctly. Well, the software would allow implementing our stuff, but there would be a little mistake because things went lost in translation. That also happened. And if everything was fine, then it had to go live on servers provided by another team, the ops team. And there too we could have unpleasant discoveries from time to time. And all of this, it could take many months, up to almost a year in some cases. And everybody thought that was normal. I didn't think that was normal. I had worked as an engineer before. It was not normal in the world of engineering to have to wait for many months for simple analysis to go live. So as to management, can we not simply at least have the IT people use the same environment that we used to develop? Because my people, when they finalized a model, it was actually running. They had a running application on our own development platform. So why reinvent the wheel? And after some politics and so, we won that battle. We aligned the environment on which we made our models. The dev people worked and the ops people worked. And it became a lot more efficient. So that's my story in 2010. Fast forward to 2021. This is my daily life in 2021. I have customers that expect models to go live in about 2 weeks. 2 weeks between requesting, build me a model and go live. I'm not claiming here that we meet that deadline today, but that's what is actually desired by the customers. They unfortunately don't have a few killer machine learning applications, but tens or hundreds. And the reason is simple. If you want to make money from machine learning, unless you're a small smart city startup with one application, you usually want to attack your retail customers from every possible angle. So that means many, many scripts. And also your internal operational efficiency you want to improve from every angle. So you have many scripts. Every script has an incremental benefit. And the sum of all these small benefits make the big added value you get out of your data. But you have to be able to keep tens or hundreds of scripts in the air without problems. You have to monitor them, you have to retrain them, there are corrections, and all of that has to go fast. My biggest headaches are the two last ones, the technological evolution. Well, I don't have to tell it to you, but there are also hundreds of open source initiatives that come and go, and you have to surf that wave, you cannot ignore it. So it's very challenging. If you ignore the wave and you say, guys, we're going to use good old commercial software suite from the 80s or so, your next problem is that your people will leave, because you have young, very dynamic people and they can go anywhere, and one of the things they want is to play with the most recent open source software actually. So that makes for a quite challenging environment, I find. Okay, now I'll briefly tell you what MLOps is, in my own words, as a manager, not as a practitioner. So there's a nice quote from the Vice President Analytics of IBM. In 2018 he met the CTO of a big American bank, and the CTO was frustrated and said, "Dennis, it only took me 3 weeks to develop a model. It's been 11 months and we still haven't deployed it." That was 2018 in a big bank. Maybe hard for you, and some of you will be researchers and so to believe that it's actually that bad, but that's the truth in many big companies. If you Google around, you will find many interesting articles that confirm what I'm saying here. And for instance, there's one from VentureBeat AI says 87% of data science projects never make it into production. I think it's a bit pessimistic, but the percentage is way over 50% as far as I can see my personal daily experience. So let's make that a little better. Definition of data and MLOps, I cannot give you a definition because really it's a loose term used for the methodologies and tools that you use to avoid all the problems that I just discussed. So it's an umbrella term used for tooling and practices to efficiently create, deploy, monitoring and maintain data analysis and machine learning scripts, basically. That's as far as I can go in defining it. Similar to DevOps, but it's not completely the same. We'll talk about that too. Okay, at this point I always do a survey to ask what is your MLOps readiness. We have very few people here, so the survey will not be statistically relevant, I'm afraid. But let's do it anyway. So 4 answers you can give. A, I don't know what MLOps is. B, I have a basic understanding of MLOps. C, I'm actively considering using MLOps. And D, I am already applying MLOps. And I'm going to launch a poll for you guys now. Yep. Okay, if all the technology works fine, you see the results. We are way too few people to have a decent poll here, but the interesting thing is that it's completely in line with what I see elsewhere where I have much bigger audiences, and about 70% of the people say I'm in category A or B, so this is starting up now. It's not yet very mature, but it's the next thing coming in the coming 2 years, I would say.
You need to read. Yeah. Very good.
Okay, thanks for this. Okay, now you see the machine learning life cycle. I've taken this from an interesting article by Seto, Vanden and Windhauser. It's on Martin Fowler. You can always download it if you want. So it shows the whole life cycle, and you have basically the 3 silos that I also encountered in my team in 2010. So first of all, you have data scientists, data engineers, data analysts that make scripts and models, and usually they do a couple of experiments and they save these experiments and then they pick the most successful model. So you have to save all these results. When you're happy with your data transformations or your machine learning model, then you, either yourself or more technically savvy people will develop into an application, real-time or batch, and will do the necessary testing. And then you deploy it and you keep an eye on it, you monitor it all the time, and if there's anything worth noticing, you communicate it to the data scientists and they will modify it and the whole cycle starts again. If you put silos in between, you have this terrible inefficiency and you have the months to go live. Better is to put all the people in your team, the people will be, so data engineers, data scientists, analysts, MLOps, and also some managers that are product owners and decision takers. You put them together, either in one team, usually that's not possible, but then at least in one task force, and you set a common set of KPIs. Some of you are maybe academics that have never heard of KPIs, but KPIs are basically numbers that qualify how well you work towards an objective here. The objective is working together and being productive. And important, at the end of the year, your bonus is linked to the KPIs. So it's highly effective to turn around the organization. And then you hope that the same happens as in classical DevOps, and you certainly work towards it. So you try to move to frequent small increments of your models. You don't wait forever to make changes. You can make the changes fast and put them live quickly. And that doing it in small increments after a while gets a lot more efficient than doing it in big bangs. You automate as much as you can, the building, the testing, the monitoring, the training, everything has to be automated. And you try to get constant fast feedback. I'm not telling you anything you don't know yet. The question is, why didn't it happen before? And the only reason is that the technology wasn't there. And now it is there, so you can basically align your development and production environments. You have automation tools, I'll talk about them. In DevOps you try to do everything as code, including the infrastructure. In MLOps too, and we code our own infrastructure, we send it to the cloud, and the cloud generates a whole account for us with all the parameters and settings we need. And everything goes in the version control. In MLOps it's a bit different. You need to version, well, not everything is code basically, you need to version other things. You have features, you have models. Models can be saved as binary artifacts, and you have to version these. You probably also want to version your training data to explain later on how you came to a certain model. You have metadata of models. All these things have to be stored as well. So there it goes broader than classical DevOps. It's also fair to say that some commercial suites like MATLAB were following this idea already like 20 years ago, but they're not able to keep up with constant new developments in Python and R, and you don't have Keras and TensorFlow and so on in MATLAB, unfortunately. So I mean, it's very hard for these classical vendors to keep up with what is happening here. Essential MLOps ingredients. So technology, I've once seen a slide where there were hundreds of open source applications on one slide, very funny slide. I don't have time to do that, so I'll just talk about the choices that we made. The first one is one that most people now make. So you have a small application, an ML model, a data transformation, so an ML product or data product you could call it. You can put it in a container. The most famous types of container are Docker containers. And these encapsulate also parts of the operating system and the libraries necessary to run your application, and nothing more. But that means that it's kind of time machine. So you make a Python 2.7 script, for instance, you put it in a container, the whole company moves to Python 3.6. Well, your container will still run, and it will still run 20 years from now, and also when you move to another cloud provider and so on. You have to run the container somewhere. One of the solutions is Kubernetes. It's an operating system for a heterogeneous group of virtual machines in the cloud. Kubernetes will schedule these Docker containers in pods, it's called, make sure they talk to each other, provide extra CPU or RAM for containers, and so on. You can run Kubernetes on premises, you can also run it in the cloud. If you go to the cloud, you have the nice feature that you can scale up. Imagine that once a week you have to do a big Spark job. You can basically then extend by 100 machines in the cloud. You do your job and then you take the machines back down. A lot less expensive than having a Spark cluster up and running 24/7, as it is the case today at many banks and insurance companies. So that is still the as is in many places. And also a lot more ecological than having all these machines generating basically heat and waste. And then you need a software to automate. Again, there are a number of options. The one we opted for is Kubeflow. So Kubeflow is a fairly new initiative of a number of very big players. It's really oriented towards MLOps. Well, in the community of Google, Dell, IBM, Microsoft and 30 other players, and also Credo is a small contributor to Kubeflow from time to time. So it's not going to disappear overnight. If you look at the community, you understand why. And it's very comprehensive. You often hear about MLflow, for instance. For me, MLflow is not a competitor of Kubeflow. MLflow covers one part of what Kubeflow aims to cover, basically, namely tracking the data associated to your models. And there are people that don't deploy on Kubernetes, but for instance want to deploy on Spark clusters, so clusters made for parallel computing. Don't ask me why you want to deploy on that, but of course it works, but it's pretty wasteful compared to Kubernetes, which uses very limited computational capacities. Okay. So we've reorganized the team. I've explained to you the tooling that I like to use. I don't say there is no other tooling, use your own tooling, whatever you want. But then you need to set up a kind of pipeline for creating new ML and data products and pipelines that support them. You do that in a lot of languages, Python, R, Spark, SQL, Scala, why not? When they are ready, you have to put these products in containers, make them microservices, also make pipelines again that support them, and you have to have a mechanism for pushing the whole thing to factory environment, and this is more restricted, so the lab is really open to all data scientists and data engineers. The factory node, it's restricted to very few people, and there you execute and monitor and log 24/7 your ML and data products, and the supporting pipelines can be in batch, can be in real time. So you can basically, with the building blocks, build something like this yourself. It takes time, but it's very, very efficient after a while. I've used the word pipeline several times by now. Pipelines are the Swiss Army knife of MLOps. They're a kind of flexible tool that you can use to make workflows, and the workflows you can use to automate and generate this end-to-end street that I've just shown. And what you do with a pipeline, well, you can do your data preparation in a pipeline, so then every time you run, the data is prepared automatically. You can generate features. I guess you all know what features are. In banking, for instance, one of the things you have in data fields is the amount on the current account of a customer. A feature would be the evolution of that amount. You can do the model training in a pipeline. And in the pipeline, you just give a few hyperparameters and then you train your model, and then you can start optimizing the hyperparameters in a very efficient way if you want. You can do all your tests, acceptance tests in a pipeline, and the monitoring you trigger, of course, also from a pipeline. I just took a screenshot of a Kubeflow pipeline, so yeah, it gives you an idea. So you create that workflow. In this case, we take a data set, we did data preparation, feature generation, model fitting, and then we did the same here, but not a model fitting, and then we do the inferencing of the model, and we get our scores basically. So that's what one of the applications of a pipeline, and each of these blocks here is basically a Docker container, so you can mix languages, SQL, R, whatever you want, and from one box to another the language can change. One of the last ingredients, model serving. So you have an ML model or data insight and you want to really make a product that can run and generate money. So you have to serve it and make it available for your clients. You can do that via microservices, so you put it in one of these Docker containers. And you can talk to the microservices via an API. So you basically have an URL, you send data to that URL and you get back your answer 24/7. Even when you do a batch run, in some cases you just schedule a pipeline and the pipeline you call a microservice, so it's very convenient to work that way. And you can deploy in different ways with it as well. So you could replace an existing application, but you can go more gradually. You could do a canary deployment, so only like 5 or a few % of incoming requests are directed towards the new ML product, and the old one takes the remaining 97% or so. So if you have big operational issues, you immediately spot it. AB is similar, but there you have a bigger sample, bigger percentage that is sent to the new model, and the aim is to test the reaction of the customers to the new model rather than whether technologically everything works fine. Blue-green, blue is the old model that runs, the green model is the new model, it runs as well, but the results are not shown to the customer, and you just monitor and figure out whether everything is fine before you go further. So all of these things become possible. And then the last technical slide, so you've put people together on one environment, everything is aligned, you have pipelines, you can do serving, everybody can be productive. But you need to transfer your work to your colleagues. You need to save your work, you need to be able to share it. For instance, you derive an interesting feature that could be used in many models of your company. You want to put it aside so that somebody else can retrieve that feature and reuse it. And for that you have the concept of stores and what you want to put in a store. First thing is scripts. Store for scripts, that's easy, that's Git, that's just a versioning engine. You can also store the features. Feast, for instance, is a new initiative that makes a store for features, so you can look it up, it's quite interesting. Then there are the artifacts. For instance, the training data. Something goes wrong with the model that you've built, and somebody has to be accountable. They come to you, what went wrong, and you look up your training data, and you don't need a store. As I tell you here, you just save that in a certain folder, and you redo the training, and it's not exactly the same. That happened to me so many times. So you have to make sure that this is clearly managed and it works fine. And there are many other artifacts, like the, for instance, the area under curve of a model and so on. All of these things can go in artifacts. Models are a special type of artifact, usually in a binary format if you use Python nowadays. And then the containers themselves, you can also store, and you can use containers to fire up IDs or notebooks in a certain container, and then with exactly the same supporting libraries and so on, you can deploy. So you're sure that what you developed will work on the factory as well. So takeaway message is simple. You need to do 3 things. You bring all the stakeholders together and you make sure the organization is aligned. You can use KPIs for that and bringing people together in teams or task forces. You have to get your development and production environment aligned, and again, some of you will be saying, why is he telling me that? That's so obvious, but the reality in many companies is that it's not aligned. And then you start to maximally automate, and you want to reach to the holy grail of CI/CD. CI stands for continuous integration, so any change you make flows through the pipeline automatically. And CD stands for continuous delivery or continuous deployment, so changes go live continuously. I'm not saying that you have to work all the way up to there. You can stop at an earlier stage and already be very efficient. And from then on, you can start every new machine learning project in your company, or I mean, say company all the time. Cities are becoming big data processors too nowadays, so it's not restricted to companies. You start every project with deployment in mind, and you try to deliver early. Put an early version live, can be in a blue-green fashion, for instance, and then you start refining. Not first working for a long time and then throwing things over the wall to the more technical colleagues. It's pretty simple, it's a lot of work to actually get it done in practice. Okay, so Gartner says a large percentage of all ML developments fail. If you don't speak Spanish, then you can Google receiptas and MLOps, and this gentleman will explain to you very precisely why all these projects fail. So I won't do it here because the gentleman is frankly very silly, but try it after the talk and maybe you will enjoy it.